Okay, here's a root sheet. This is all you're going to need. It's only, you got your squares, your cubes, and your fours. Just rip that off, and then we're going to go to town here. These are example problems that will help you with the actual assignment. So it's a fourth root, and 625 is there, so it's 5. Now, I don't know if he freaks out. If it's an even, it could be positive or negative. If it's odd, it's only the one sign. But I don't know. I'm not going to put that on here. So cubed root, 24 is not a perfect cube, so I make 2 cubed roots, and then I start dividing 24 by these numbers. Now 24 is divisible by 8, and the result's 3. So this cubed root of 8 becomes a 2. So it's 2 cubed root 3. Okay, now when you got variables in there, what I like to do, I've always liked to do, now you can have a negative under an odd degree root. Okay, you don't have to extract the I, that's when it's even. And I go cubed root of x to the 7th, okay. All right, now 27 is a perfect cube, it's 3, but in this instance it would be negative 3. If you got x to the 7th, remember what that means. X to the 7th is 7 factors of x. Now you'd group them into 3s. You put a cubed root over 3 of them at a time. Well, I didn't mean to do that many. 3 of them. And then that's 2 full cubed roots. So that ends up being x, that ends up being x to the 2nd because you got 2 full roots. Then you got this one here that would be in a cubed root all by itself. So it's x squared cubed root of x. So here's how you write your answer. You put your negative 3 down, followed by x to the 2nd, and then the cubed root of x. Really, you can just do that in your head. You know you can get 2 groups of 3s, so x to the 2nd, and there's 1 remaining. So that's why it's x is still in the cubed root. Okay, fourth root, same idea. Okay, now 405 is not a perfect fourth root, so you would divide, it divides by 81. So 405 divided by 81 is 5. And the fourth root of 81 equals to 3. That's because 3 to the 4th power is 81. Now, how many groups of 4 can you get out of 5? You can get 1, so I'm just going to put x. There'd be 1 remaining in the fourth root, so that's x. Okay, if you have 7, how many groups of 4 can you get? 1, so it'd just be y. There's 3 left over, so you got y to the 3rd in the fourth root. Okay, so what I do then is put the 3, give yourself some room and put a fourth root, and then you put 5 inside. You get x outside, x inside, and then y outside, y to the 3rd inside. That's how that works. Now look, if you got a fraction, it's really not that big of a thing, okay, with these roots. First off, you reduce 6 over 48. You can reduce those by 6. That'd become a 1. That'd become a 8. So then what I'm going to do is 1 and 8 happen to both be perfect cubes. So then in my answer, it's now 1/2. Now, x fourth, x 7th, we'll get rid of the x to the 4th, and we'll have x to the 3rd down there. So it's really like the cubed root over x to the 3rd. So I could get 1 full group out of that. There wouldn't be any remaining, so that would just be x. So I wouldn't need a root because there's none remaining. But I got to remember to put that on bottom because that's where the x to the 3rd was at. It's on bottom, and the y's just cross out. Okay, multiplication with roots, as long as they're both the same kind of roots, they'd be square roots, you can go ahead and multiply them. It's kind of a 3-step procedure, okay? First thing you do, you make one root, as long as they're both square roots. If you have a square and a cube root, it's not going to work that way. So we're going to multiply 3 by 27, that's 81, and then x and x to the 5th is x to the 6th. Okay, so that's your first thing. Now your next thing is you go off this side and break it up. Okay, so you got the square root of 81, the square root of x to the 6. Now the square root of 81, 81 is a perfect square, that's 9. Okay. Now you're grouping them by 2's, that would be 3 full groups. There would be none left over. Okay. So that would be 9x to the 3rd, and there's really nothing else I can do with that, so that is the answer. I can just stop there. Now you got another multiplication, but you got a little problem, okay? The problem you have is that this is a square root, that's a cubed root, so that you can't multiply them together. They have to be the same kind of root. What I would recommend you do is rewrite the roots as exponents with fraction form. Okay, so I'm going to rewrite this. I'm going to write just 6. But if it's a square root, it's to the half power. And then the 8, it's a cubed root, it's to the 3rd power. Now that second power is still there. So what I'm going to do is multiply each of the powers by 2. So I just can take 1 times 2, that's 2, and 2 over 2 would be 1. Now 2 times 1 is 2, but that one you can't really do anything with, like you could with 2 over 2. So now that power outside's gone. So 6 to the 1st is 6. Now here's how we figure out 8 to the 2/3 power. Now you're going to go back to a root, okay? You're going to put 8 inside the root. Now the bottom number means it's a cubed root. And it's to the 2nd power. So the cubed root of 8 is 2, because 8 is a perfect cube, and it's 2 to the 2nd, so that's 4. So this now is actually 4. So 6 times 4 is 24. Okay, now we got the same problem on the next one, because we didn't go over this last year. Okay, so again, rewrite, they're different roots, rewrite them as fraction exponents. 6 to the 1/3 power times 5, and that would be to the half power. And then I just multiply each of these exponents by 4. So 4 times 1 is 4. You can't do much about 4 over 3. 4 times 1 is 4. 4 over 2 simplifies to 2. Now the 4 is gone. So 5 to the 2nd is easy enough. That's 25. And over here, we got to simplify that. So again, you make a root, you put a 6. The 3 on the bottom means that's what root you have, and then it's all to the 4th power. Problem is, the cubed root of 6 doesn't work out very well for me, okay? Because it's not like 6 is a perfect cube like the 8 was up there. So it's on to plan B. You're going to keep your cubed root, and you're going to raise the 6 to the power of 4. You can do it in different orders, okay? I mean, here I wouldn't have, because I already had it right away, okay? I mean, I could have done 8 to the 2nd first and got 64, and the cubed root of 64 is 4, and that's exactly what I got, okay? And you can do it that way every time. Maybe you just want to raise it to the power, then do your root. It doesn't matter. So I go 6 to the power of 4. It's 1,296. Now you're going to want to simplify that into 2 different cubed roots. 1,296 divides by 216. You'd have to play around with it. It's 6. Now the cubed root of 216 is 6 whole. So you now have 6 cubed root 6. Now you can multiply 25 by 6, and that's going to be 150 cubed root 6. Again, if they're not the same root, rewrite. Up here they're the same root, so you just go multiply away and then simplify it out. You're going to write them as fraction exponents, and that is multiplied into each of your fractions, okay? And again, some of them, sometimes they just simplify on the spot. Other times you have to go over here. Remember, if the root isn't available, then you raise it to the power first, then simplify it. Then I did something stupid. You want to turn to this page here, because the packet's out of order. Addition is easy, okay? It's not like multiplication. Addition, they have to have the same roots, okay? So I look under the roots, they're like terms. That means I can add 8 to 10. 8 plus 10 is 18, and then you leave it as the square root of 5. Now, if they are not the same root, I'm going to make this table over here, and I'm going to simplify each one of these. Okay, if I drop the 3 and drop the 5. So from the square root list, remember, if it doesn't have a number up there, it's a square root. So 12 is divisible by 4. So I make 2 square roots, and I put 4 and 3. So square root of 4 is 2, and that becomes 6 square root 3. 27 is divisible by the perfect square of 9. So divided by 9, it's 3, and that's 3. That's 15 square root 3. Now you can rewrite this as 6 square root 3 plus 15 square root 3, and now you got the same roots. Remember, to do the adding and subtracting operation, they have to be the same. That's different than multiplying. Multiplying, as long as the roots are like the same. By the same, I mean square root, cubed root, fourth root. You can just go to town, but here, and then that's going to be 21 square root 3. Okay, now you're also going to run across problems where you have to do the FOIL method. Or let's go down here, this last one. Okay, pay attention to your minuses and pluses. Okay. Make that a plus negative probably. And then we're going to come over here and we're actually going to make a chart, but it's going to be 3-sided. Because I'm going to simplify the cubed root of x of 16, x to the 4th y. Then I'm going to simplify negative 3x, and then the cubed root of 2xy. And then I got 5. By the way, if you have a negative and a cubed root, you just can move it outside, so the 5 will go negative. That's how that can work. Cubed root of now 2xy to the 4th. Okay, so now what I do, I say, okay, what can I divide 16 by? In the cubed root list, you can divide it by 8. Okay, so I rewrite that. I divide it by 8, and I got 2. So that would be 2 cubed root 2. Now, look at your exponents. How many groups of 3 can you get out of 4? 1. So x out here, there'd be an x left. Now, you can't get any groups with the y, so that y stays. Okay, so I rewrite this as 2x, then the cubed root 2xy. Okay, then we move over here. Now I'm pretty sure that's already simplified because, I mean, 2 isn't going to divide by anything other than 1. And then x to the first, y to the first, you can't get any groups of 3. So this was already in simplest form. So negative 3x cubed root 2xy. Okay, then finally, 2, again, same thing. So the 2's got to stay there because I can't divide 2 by any of the perfect cubes other than 1. You can't get any groups of 3 out of just one x, but you can get one group of 3 out of your y to the 4th. So I'm going to move a y outside, okay, 2x, and then there'd be 1 left over. Okay, that's the easiest way to do that. So negative 5y, and then the cubed root of 2xy. So now all the roots are the same. There, and there. So now you can just make it into 1 cubed root with 2xy, and then you can simplify, okay? So 2x plus negative 3x would be negative 1x, and then that plus negative 5y, I would just put that outside here, okay? Because that won't go, you can't add that to x, so you're going to put a parentheses in around it, okay? That's kind of complicated, so again, all end up the same. You combine your like terms and negative 1x, and then you put the other non-like term behind it. Make sure you put it in parentheses, though. Okay, now the next one, you have to do the FOIL method, okay? So you have square root of 5 times square root of 5. Back to the square root of 5 times negative 7. 6 times square root of 5, and then 6 times negative 7. So that's the square root of 25, but that's 5. Okay? This would be, you don't multiply these, you just write negative 7 with a square root of 5, and that'd be 6 with a square root of 5. And this here would be negative 42. Now I combine those two, that's negative 37, and then I can combine those two. Negative 7 plus 6 is negative 1. But you just keep that at the square root of 5 then, because that's an adding, subtracting thing I'm doing. So once it's common, you keep it. Okay, now we're going to go back to this right here. Now you're going to get these problems that say, no, that's the wrong page, sorry. It's going to say rationalize. Here's what that means. You make another fraction, and you're going to multiply by the square root of 5 because you're trying to get rid of that. So on top, you're going to have 3 square root 5. And then on bottom, I take the square root of 5 times the square root of 5, which is the square root of 25. Now, we all know that that's 5, okay? And that's the answer, 3 square root 5 over 5. I hate this, the rationalizing. Okay, same idea on the next one. Square root of 2, square root of 2. Now what you do, you're just going to put the negative in the front, and you can multiply now. Up here you can't because that's a whole, that's a square root, but these are both square roots, so that's the square root of 14. And then this is the square root of 4, but we all know that that's 2. By the way, you're not going to reduce that because the 14 is in a square root, the 2 is not. Now, if you have a plus or minus operator in the denominator, what you have to do something different. You need to switch that expression to plus and 6 square root of 5, and then 6 plus square root of 5. And this is a little bit longer then. Okay, so I need to multiply two things. I need to take the square root of 6 times 6, and then I got to take the square root of 6 times the square root of 5. That isn't hard. That's going to be just 6 square root 6, and that's square root 30. So that's your top, 6 square root 6 plus the square root of 30. Now the bottom, you're going to FOIL. You're going to take 6 times 6. You're going to take 6 times the square root of 5. You're going to take negative square root 5 times 6. And then you're going to take negative square root 5 times positive square root 5. So that's 36. That's just 6 square root of 5. Now a negative times that's going to be 6 square root 5, except it'll be with the negative. So these cancel out because they're exactly the same, but one's positive, one's negative. I put negative, and then I take that square root of 25, but we all know the square root of 25 is 5. Okay? And then 36 can now be combined with the negative 5 to make 31. And now it's rationalized. Okay, we're going to be doing the same thing here. When I see that, again, when you have just a single square root, this is what you do. But when you have a more complex one with a plus or minus, you switch the plus to a minus. Okay, and then right here I execute the FOIL method because there's 2 terms here, 2 terms here. So I'm going to be taking 8 times 8, and then 8 times negative 2 square root 7, and then negative square root 7 times 8, and then negative square root 7 times negative 2 square root 7. So that's 64. That's negative 16 square root 7. This is going to be a negative, but I don't multiply those. I just write 8 first and then square root 7. These will be combined. Negative times a negative is a positive, so we can forget about the negatives. We put 2. And then I multiply the 7s together to get 49. So we know that that is 7. Well, 2 times 7 then is 14. So that's 64 plus 14, which is going to be 78. And then negative 16 plus negative 8 is negative 24. And then you put the square root of 7. Okay, now at bottom, you're multiplying conjugates. Those are called conjugates, okay? Now you notice how these crossed out. That always happens when you multiply conjugates. So if I were you, I'd just take 8 times 8. And then 2 square root 7 times negative 2 square root 7. So that's 64. That's negative 4 with square root 49. But the square root of 49 we know is 7. So that's negative 28. So 64 minus 28 then is going to be 34. Okay. So yeah, those aren't real fun. Those rationalize the denominators. Okay, now next one, you're going to be doing fractional exponents, okay? You're going to turn back to here, and here's how you're going to simplify this. I know he doesn't let you use a calculator, so you need to simplify it like with, I mean, you can use it on your own probably. Here's what a fractional exponent means. It's actually a root with a 27 inside. Now the 3 on the bottom means it's a cubed root, and then it's to the 4th power. So is 27 a perfect cube? Yes, it is. It's 3. And then it's 3 to the 4th power, which should be 81. Okay, same idea here. Put your negative 81. Make that a positive. I wrote that wrong. Okay, you can't have a negative with an even root. I'm pretty sure I just wrote it like an idiot. So the 4th root of 81 is 3. And then it's raised to the 5th power. 3 to the 5th power equals 243. Now, if your power is a negative, you're going to make it positive, judging by the assignment. You're going to make a fraction with a 1 over it. And whatever I get now is going to go here. So I got 16 with a 2 raised to the 5th. 16 is a perfect square. It's 4. 4 raised to the 5th. Is going to be 1024. So yeah, I didn't do a lot of this. I got into a little bit of it. Gotcha. Okay, let's do another one where we have to rationalize the denominator. I know that was a little bit off kilter, but we're going to times. Remember, we got to switch the plus to a minus. And then here, I'm just distributing. I'm taking negative 5 times 6, and then negative 5 times negative square root 7. So that's going to be negative 30. That's a positive, and I just put 5 with the square root of 7. So negative 30 plus 5 square root 7. Now on the bottom, we see conjugates. So I know the FOIL, I just do the F and the L. Okay. So I take the square root of 6. Wait a second. Yeah, I need to put, I did that wrong. It needs to be the square root. Oh, God, I screwed that up. Just rewrite the problem down here. Okay, it's 5. Negative 5 over the square root of 6 plus 7. So it's the square root of 6 minus 7. Okay, and then the square root of 6 minus 7. Okay, so again, I distribute. I take negative 5 times the square root of 6, and then negative 5 times negative 7. So that's going to be negative 5 with the square root of 6, and that's 35. And the bottom are conjugates, so you're just going to multiply those two. So square root of 6 times square root of 6, and 7 times negative 7. Well, we know that's the square root of 36, but that's actually equivalent to 6. That's negative 49, so I combine those, it's negative 44. Okay, now right here, with a cubed root, it's a little bit more dicey. When it's a cubed root, you're going to rewrite that as 5 to the 1/3 power. Now, you don't have to do any of the FOIL and all that stuff, the distribution. But when you multiply, you're actually going to multiply by 5 to the 2/3 power. Because here's what happens. What you do is you add the powers. Well, 1/3 plus 2/3 is 1 whole. Okay? So it'd be 5 to the 1st, which is just 5. Now up here, you're not going to multiply those because that has a power. That one doesn't. You're going to write 9, and then you probably want to convert it back into radical form. Okay, so 5, 3 on bottom, and you just go to the second with that. That's how I would do it. Okay, now that's how you rationalize denominators. So then with these, back to the powers with the fractions. Okay, so remember that shouldn't be negative. I screwed it up. It can be negative if the root's going to be, so you make a 1 over it, so you can make your exponent positive. 16 with a fourth. You don't really need it the 1 out there because the fourth root of 16 is just 2. So that'd be 1/2. Okay, remember you are still going to put yeah, just put the 1 over it. Just get in that habit. Okay, you can make that positive. Now, when you have a fraction, both of these inside go to the 2/3 power. Okay. I would put the negative with the top then, okay, if you have a negative like that. So I'm going to put -8. I'm going to go off the side and simplify both of them. So I'm going to go -8 cubed root, and it would be to the second power, and then we'll just go 27. Remember, the negatives just goes with one of them. I would put it with the top. Okay, the cubed root of 8 is 2, but it would be -2. But -2 to the second is 4. Okay, so that top now goes to a 4. And then this right here is 3 to the second would be 9. Now that looks really awkward, so what you're going to do when you have a 1 over a fraction, you're actually going to get rid of the 1 and flip the bottom. Okay, so 9/4 is the answer. Okay, next one, 1 over it. Make it positive, and now you can go to your root. So -27, it's a cubed root to the second power. So that's -3 to the second, and that's 9. So I put 9, and that's 1/9 simplest. It's not simplified when you go 1 over 4/9. You just kind of flip that bottom, and the 1 can go away. All right, don't need the 1 over it. So again, I just take each one of these to the 3/2, okay? And then we go, it's a square root, 16 to the third. Square root, 27 to the third. Okay, now square root of 16 is 4 to the third, 64. There's your numerator. Now the bottom, it's a little bit dicey, okay? Because 27 is not a perfect square. What I would do if I were you, because if I take 27 to the third first, that's an outrageously high number. What I would do is just do your 2 square roots. You know you can divide 27 by 9. That's 3. So that's 3 square root 3. Now what about the third power? Well, here's what you're going to do. You're going to take your 3 to the third power, and that's 27. Now with your root, what you're going to do is simply put parentheses square root 3 to the third power, and I would just leave it like that if I were you. That's probably good enough. So again, you simplify the root, and then the outside number you raise to the power, and then if it's in a root, you just put the root in parentheses with the power outside. Yeah, this is no easy assignment. It's challenging. Okay, same thing here. I don't need the 1 though. So I'm going to take 125. It's going to be the square root, and then, or no, the cubed root raised to the second. Then the 8, it's going to be the cubed root. Remember, the bottom number is your root. The top number is the power you raise it to after the root's done. Okay, so the cubed root 125 is a perfect cube. It's 5, but 5 to the second then becomes 25. The The cubed root of 8 is 2. 2 raised to the second is 4, so it's 25/4. Okay, now we did these last year, okay, with all the variables. So you're going to make 3 lines. You're going to put your x, and then you're just going to add those. 1/3 plus 1/2 plus negative 1/6. Okay, it's going to be 2/3, so x is to the 2/3. It's not negative, so it's going to stay where it is. And I can't really evaluate it because it's a variable. Okay, now you got x and y as your variable bases. You got to take 4 times 1/4. That's 1. And you take 8 times 1/4. That's 2. Neither one of them are negatives, so they're both going to stay where they're at. Okay, so you got 6 times x times y. Now the 6, 1 times 4/3 is 4/3. Now the x's, there's 2 of them. So the first one I got to take negative 1 times 4/3. It's negative 4/3. And then I'm going to minus, okay, because it's on bottom. 1 times 4/3 is 4/3. So I go negative 4/3 minus 4/3. Now you don't want a mixed number with your exponents. So you go second ABC equals, and it's negative 8/3. Okay, now the y, you're going to take 1/2 times 4/3. Now, when I times 1/2 by 4/3, it's going to be 4/6, but that's 2/3. And then I subtract 4/3. That's negative 2/3. Okay, now the ones with the negative exponents have to move to the bottom. Okay, so x to the 8/3 power on bottom times y to the 2/3 power. Those will both stay the same. Now, 6 to the 4/3 power is, are you going to evaluate that? You're going to make your radical with 3, and you're going to put a 6 inside to the 4th power. Now, if I try to take the cubed root of 6, not only is it not a perfect cube, it doesn't divide by anything. So I'm actually going to do my power first. Now I'm going to take 6 to the 4th power. It doesn't matter the order you do it, okay? It's 1,296. Now try to divide that. That does divide by 216, so I need to rewrite it in 2 cubed roots. So 216, and the result is 6. The cubed root of 216 is 6. So you got 6 cubed root of 6.